So we are talking about the law of sines, and the note guide for this will be in your packet here. But first of all, before we get to the note guide, if you look at this picture, it says a rescue boat spots a hiker on the edge of a rock shelf. How far is the boat from the hiker? So we're trying to find this distance x right here. And so my question for you is can we solve that triangle by using SOHCAHTOA trig? Can we use trig there? SOHCAHTOA. The answer is no. Jackson, do you know why? We don't have a right triangle, exactly. SOHCAHTOA is when you have right triangles. That's called right triangle trig. And so we can't use that. Now we can use it in a roundabout way if we were to drop in a perpendicular line here. And so we could use SOHCAHTOA on this side of the triangle right here. So we could figure out what this length is right here. We could figure out this length, and then we could figure out that length. Let me think here. And then we could work through then and figure out another length. All right, so that would be one way to do it. But what we do have is called the law of sines, which is the sine of angle A over side A equals the sine of angle B over side B, which equals the sine of angle C over side C. Keep in mind with with any triangle, if you name the vertices with capital letters, the sides across are named with the same letter but a lowercase one. So you can use the law of sines to find missing measures of any triangle when you know the measures of two angles and any side. So we're not talking right triangles here. Two sides and an obtuse angle opposite one of them. Two sides and acute angle opposite one of them. And so let me just show you kind of how this works. So it's similar to what I talked about before. If you have a triangle and you have a segment with the height in, you could say that the sine of A, so the sine of angle A would be the opposite, which is 8, or H, over the hypotenuse, which is B. So H over B. The sine of angle B, right here, is the opposite, which is H, over the hypotenuse, which is A. So now you have the sine of A equals H over B, the sine of B equals H over A. So if you solve each of these equations for H, so you multiply by B on both sides here, H would equal B sine A, multiply by A on each side, H would equal A sine B. Now since B sine A and A sine B equals H, you can set them equal to each other. So you have B sine A equals A sine B. Now if you divide both sides by AB, what happens then is you end up with sine A over A. And when you cancel here, you have sine B over B. So this is how this is developed using algebra. And then you could, again, draw on another line and figure out C, and then you would end up with this law of sines. Now let me show you how it works. It's kind of cool. So it says in triangle ABC, the measure of A is 48, the measure of angle B is 93, and the length of AC is 15. To the nearest tenth, what is the length of BC? So I'm going to put an X right here. So this is in your note guide now. And so we can use the law of sines because you know the sine of B and the side across from that. So you write the sine of 93 and the side across from that is 15. So basically we're using a proportion. And that's going to equal the sine of 48 and the side across from that. And so you know 3 out of the 4 parts, so you can cross multiply and solve that. So when we cross multiply, you have x times the sine of 93 equals 15 times the sine of 48. Now we are talking about degrees. It says 93 degrees. So when you type this in your calculator, you have to make sure that you're in the degree mode. Some of us switched to radians yesterday, so make sure you're in the DRG degree mode. And so then to get x by itself, you divide by sine of 93 on both sides. So in your calculator, you can type in 15 times the sine of 48 and make sure if there's a parenthesis there that you close it in the numerator. So it'd be 15 sine 48, close the parenthesis, and then hit divided by sine of 93. And you should get 11.2. Do we agree with that? So when you know 3 out of 4, 2 angles, the sides opposite, you can use the law of sines with any triangle. So again, notice this isn't a right triangle we're working with. So what is the length of AB? So now looking at this, we have 93 and the side across from that is 50. 93-degree angle, side across from that is 50. Now in this case, across from the X is angle C, but you don't have that either. But do we have enough information to figure out what angle C is? Can we figure that out? How do we figure that out? Yep, add the two angles together. Remember in a triangle, the angles all have to add up to 180. So 93 plus 48, and you subtract that from 180, and you get 39. So angle C is 39. So the law of sine says the sine of 39 over the side across from it, which is x, equals the sine of 93, and the side across from that is 15. So across from big B is little b, across from big C is little c. So it's the sine of angle C over side C, the sine of angle B over side B. So we cross multiply, so we would have x times the sine of 93 equals 15 times the sine of 39. And to get x by itself, we divide both sides by sine of 93. So 15 times sine of 39, oopsie, divided by sine of 93. So we get x equals 9.5. All right, so let's look at the next one. We have to find the measure of angle S. So actually, I'm just going to put a little x right there. So what we have is we have angle R and the side across from it. We need angle S, and we have the side across from that. So we have 3 out of 4. So again, we can use the law of sines. So the sine of angle X over the side across from it is 11. Equals the sine of 120 degrees and the side across from that. So we will cross multiply. So you will have 18 times the sine of angle X equals 11 times the sine of 120. Now, this is a little different because we're solving for an angle. So again, though, we want to get everything on one side. So keep in mind when you're solving for an angle, what we do on the calculator is we use the inverse. So sine inverse of whatever this is over here. And you can type that into your calculator. Just watch your parentheses. So we're going to hit second function sine, and then we will have 11 times the sine of 120, and close that parenthesis behind 120, and then divided by 18. And then you need to close that parenthesis again. So you should have 31, it would be 32 degrees approximately. So type that out, make sure you get that on your calculator. Okay, questions on that? All right, let's do another one. So on your test, actually, this is how your problems are going to look. You won't have a triangle, so what you're going to want to do is draw a triangle and label it. Just a generic triangle will be fine. KLM. So draw the triangle, label it. It tells us that the length of LM is 9. The length of KM is 14. And the measure of angle L is 105. To the nearest tenth, what is the measure of angle K? So I like to make my crisscross there. So we have angle L and the side across from it, and we're looking for angle K, and we have the side across from that. So the sine of angle K over the side across from that is 9 equals the sine of 105, and the side across from that is 14. So we will cross multiply. So you have 14 times the sine of K equals 9 times the sine of 105. And we divide by 14. So again, we're looking for an angle. So we're going to use the inverse of sine. And then you can type in 9 sine 105 over 14. And then you'll have to have a closing parenthesis there. And you get 38.4 degrees. Do you agree? Okay. All right. And I'm just looking here to see what else we have here. Let's see. And I think we will call it good right now. Actually, I think there was one more I wanted to do here. Gotta look for a second here. We are looking for RQ. So RQ is right here. I'm going to put an X right there. Again, you don't know the angle here. We'll just set this up. So first you have to add 32 and 39. And then subtract 180. Or subtract that from 180. So this is 109. And then you can set this up, sine of 109. And then you have also angle 39 and the side 40. So the sine of 109 over X equals the sine of 39 over the side across from that is 40. So we chose 39 because we know the side across from it. We didn't know the side across from 32, so we're not using that 32-degree angle. All right, so that is it for this lesson.